na namang episode na punong-puno ng kaalaman. Mundo ng numbers atin yung pag-uusapan. At ano pang hinihintay nyo? Halina't MATH-TUTO! Are you ready for a fun-filled discussion? By the way, I'm your math teacher for today, Ma'am Ivy Picardal. Get your learner's packets, answer sheets, and ballpen, and stay tuned in another exciting Grade 7 Mathematics lesson only here at HALINA'T MATH-TUTO sa Dasmariñas North National High School. Hey guys, our lesson for week 4 of quarter 1 is the properties of operation on integers. Today, you are expected to illustrate the different properties of operations on the set of integers. And these are the properties of addition of integers and the properties of multiplication of integers. One of the properties of operation is the closure property. Why is it called the closure property? That is because two integers that are added or multiplied will remain as integers. Hence, integers are closed under addition or multiplication, which means that the sum or product of integers will also give integers. Here are some examples for the closure property of addition and multiplication. We have 7 plus 12 is equal to 19. We all know that 7 and 12 are integers. Thus, their sum 19 is also an integer. Another example for addition is negative 15 plus 12 equals negative 3. We all know that negative 15 and 12 are integers. Therefore, their sum negative 3 is also an integer. For the closure property of multiplication, we have 5 times 9 equals 45. And 5 and 9 are integers. So is their product 45. And finally, we have negative 3 times 8 equals negative 24. Negative 3 and 8 are integers, giving us a product of negative 24, which is an integer. The next property is the commutative property. Changing the order of the addends or factors does not affect the sum or product respectively. For example, we have 6 plus 2 equals 2 plus 6. What makes this equation true? We all know that 6 plus 2 is equal to 8 and that 2 plus 6 is also 8. Thus, 6 plus 2 really is the same as 2 plus 6. An example for multiplication is 7 times 5 equals 5 times 7. Why is this true? Because 7 times 5 equals 35 and that 5 times 7 is also 35. Holding it true under commutative property. In other words, we can add and multiply numbers in any order. In addition and multiplication of integers, changing the grouping of addends or factors does not affect the sum or product respectively. This is called the associative property. Integers can be grouped in any order. The sum or product will still be the same. Let's have an example. We have the quantity of 3 plus 7 plus the quantity of negative 4 equals 3 times the quantity of 7 plus negative 4. we change the grouping of the addends from the quantity of 3 plus 7 to the quantity of 7 plus -4. Let's see if this holds true to both sides of the equation. Recall PEMDAS. We solve those inside the parentheses and then we work ourselves out, giving us 10 plus -4 equals 3 plus 3. Solving this, we have 6 on both sides. Thus, the quantity of 3 plus 7 plus -4 is equal to 3 plus the quantity of 7 plus -4. Now let's try the same property but this time in multiplication. Let's see if the changing of the groupings does hold true in multiplication. Is the quantity of 4 times 5 times 7 equal to 4 times the quantity of 5 times 7? Again, using the rules of PEMDAS, we have 20 from 4 times 5 times 7 equals 4 times 35 from 5 times 7, giving us 140 on both sides. Therefore, the quantity of 4 times 5 times 7 equals 4 times the quantity of 5 times 7. Now, have you ever noticed that whenever you add a number or integer to 0, the answer will still be the number itself? This is actually called the identity property of addition. The 0 is called the additive identity. For example, 15 plus 0 equals 15. 0 plus -8 equals -8. And what about 0 plus blank equals -18? You got it? It's -18. There you go. In multiplication, when we multiply an integer to a certain number, the product is still the integer. What do you think this number is? That's right, it's 1. The product of an integer and 1 is the integer itself, meaning whenever we multiply an integer to 1, the product is the integer itself. 1 is called the multiplicative identity. Here are some examples. 32 times 1 equals 32. 1 times -15 equals -15. And what do you think is the product of 1 times -20? Very good. Their product is -20. In mathematics, the term we use for opposite is inverse. When we add opposite integers, the sum is 0. In other words, the sum of any number in its additive inverse is 0. This is called the inverse property of addition. Let's have some examples. We have 10 plus -10 equals 0. The additive inverse or opposite of 10 is -10. Thus, adding them will give us 0. The same holds for -2 plus 2 equals 0 and 23 plus -23 equals 0. In the inverse property of multiplication, the multiplicative inverse is not the opposite sign of the integer anymore. It is rather the reciprocal To find its reciprocal, simply divide 1 by the integer. For example, find the multiplicative inverse of each number. Letter A, 3. So divide 1 by 3, which is 1 over 3 or 1/3. Letter B. What is the multiplicative inverse of negative 17? You got it? It's 1 over negative 17. Yan. Going back to the property, if we multiply a non-zero integer, meaning any integer not including 0, and its multiplicative inverse, the product is 1. Let's multiply the integers and the reciprocal from our previous examples. So we had 6 times 1 over 6 equals 1. 1 over negative 17 times negative 17 equals 1. As you can see, their product will always be 1. And finally, the last property of operations on integers is the distributive property of multiplication. We are all familiar with the word to distribute. We use this when we used to have activities or exams in class, and the teacher tells us to distribute the paper. It's similar in math. When we distribute or multiply an integer by each addend,
the distributive property tells us that we can add first and then multiply, or multiply first and then add. Either way, the multiplication is distributed over all the terms inside the parentheses. Here's an example. Negative 5 times the quantity of negative 3 plus 10. Let's distribute or multiply negative 5 to each term or addend in the parentheses. We have negative 5 times negative 3 plus negative 5 times 10. Now let's see if the property holds true by simplifying both sides separately using the rules of PEMDAS. We have negative 5 times 7 equals 15 plus negative 50, giving us negative 35 on both sides. Thus, the distributive property of multiplication, negative 5 times the quantity of 3 plus 10 is equal to negative 5 times 3 plus negative 5 times 10.
Since everything is clear, you may now start answering the learner's task of the week, and don't forget to like, share, and subscribe in our YouTube channel so you will be updated in our latest uploads. At ayun na nga, natapos na naman ang ating talakayan. Hanggang sa susunod na linggo, dito lang sa programang punong-puno ng kaalaman, mundo ng numbers ating niyang pag-uusapan. Kaya't ano pang hinihintay nyo? Halina't matuto!